This is pretty much the design I came up with to pick up all my sawdust. Got these mini shop vacs. They're nice. You can hang them up on the wall. They're light. And I can remove this. Don't need that no more. Bing, boing. So I still have to find a way to attach this to the main spindle. Let's say I'm thinking of Velcro around here. That's probably going to be the most likely thing, because it's just I'm thinking up of all kinds of ways to clip, but I mean, I'm fed up. I want to get this done. This slides off, and on this could stay attached, and you only slide off this attachment, which will have the curtains, I guess we could call them, but this one is 1.5 millimeters thick, and that's still too stiff. As soon as there's a curve here, and you could, if I have to drill a hole, this is extremely strong. So, I mean, on the straight back here, I have, let's take this off so it's easier. I made this modular design so that I could change this. I could change its mate in the back without undoing everything, you know, and have different length curtains for different length bits and different work. Like if I'm just skimming the surface, if I'm milling the surface like PCB circuits, I'll always be using, you know, only need to be 2 millimeters off the ground. But if I'm drilling through the PCB, then I need to be a little bit higher, let's say 4 millimeters, you know. So I don't know yet what, could I just put a 4 millimeter gap and I'll be good? I don't know. That's what testing will reveal. And fingers in the lens, nice amateur. So this is how I get to my tool, my nut. I can slide my 2 Allen keys, or 2 Allen keys, spanners, whatever you want to call these guys. Slide them in there, undo the thing, undo the change bit. And I could also, you know, raise this up and give myself more room, because right now it's just, I was testing depth, and that's it, you know. Slide this back on. Is that on? Yeah, it's on. It's just that to put this guy on, I might have to put the camera down, because my room in back, because of this guy, I have just enough room for the curtain to pass, you know. So it's a snug fit. And it just slides on like that, in theory. But right now, it's buckling on the other side. We can see where the, oh, you know what I mean. Just goes back here, slides in, and then I have to find a way to, same thing again. I'm probably going to go with Velcro. It's the easiest, because clips, to be printing these things on 3D printer, I don't print it flat, because if you print it flat on its back, you can't get these straight edges. You can get the bottom one, but then you can't get the top one. So what I do is I print them standing up in an arch pattern like that, with, you know, support pads and braces, and then I snip everything off and then pass with an X-Acto and clean it up as much as I can with a box cutter. And that's how I've printed all of these parts. This one is crazy glued in, but I mean, this tube was printed upside down like this. That's why there's a V here to be able to make this sledge. Because you can't make a 90-degree bend. I've tried and that was a disaster. So this tube is printed standing up like this. This casing is printed like this. And as the printer goes up, slowly, it just keeps going further and further. You have to do a little bit of sanding here because the edges aren't, you know, super smooth. See, this one I didn't bother too much with it, but I mean, it's good enough for what I'm doing. And the most important edge on this case is the outside one. The inside here, I don't really care. This inside one here, though, that's something else because that one has to fit inside here. And I did a little bit of pushing and hemming and hawing with a blade, and because I don't have a deburring tool, it's going to take like another 2-3 weeks for it to get it delivered. Same thing with this part. It's printed like this, and I do the same thing. I put cross brace and I put a large contact patch because it has to stick to the board, or else it just gets knocked off or starts moving around. I mean, that's not enough. Let's call it adhesion. So you have to make an adhesion pad, then you have to make braces, or else as soon as it starts curving the walls, boop, they fall over. So lessons learned. And this part was done in 2 pieces. Printed the bottom 2 rings on their back. Then I printed the next 3, yeah, the ones that go all the way to the back. The next 3 were printed this way. So again, I had some sanding to do on the inside here so that it fits snugly onto the motor, but it's no big deal. And then you can't see it, but there's a, yeah, there's a little ring there. You can see the line. I focus on that. Not much. And that's where they're joined, crazy glued. I have an outer ring on one piece and then the inner ring on the other piece. Like, let's say the bottom one might have an inner ring, and in the next section, in the top part, it's got a hollow area for the inner section. So it just fits in snugly. Crazy glue, and you make sure to put it 90 degrees and glue it, and try not to glue your fingers, because I've made my gap here. Through here we could actually see the light. When we held it up to the light, we were able to see through it. So I mean, live and learn. It's my first real attempts at making 3D shit. So that's how I get along to assemble all my stuff, and how to be able to make it in a modular fashion. Came up with this design, like a tube shape, and then 2 grooves to stop it from falling down. And at the bottom, it's just like 2 grooves. So it's not complicated. It's just hard to fine tune because my 3D printing skills aren't perfect. My 3D printers, when it starts off, it smushes one of the ends. They don't get perfect adhesion right off the bat. So one of the ends looks like a cripple. The other end looks super fine. You know, it's great. It's just this one, like, eek. But no big deal. It's not a beauty contest. And it works. It's just that now I've got different thicknesses of this. Well, they call it tablecloth, but I can't imagine a tablecloth with 1.5 millimeter. I've got some, because since I didn't know how strong I needed, I've got this, I've got some 0.5, and I've got some 2.7, I think it is. 2.7. I don't know what I'm going to do with it. Probably a tabletop, or maybe put it even on my workbench. The thing is ultra thick. It's just not, it has no give. I mean, this one is 1.5, and you can see that it's got some stiffness. As soon as you curve it, it can take weight. It's got strength to it. So I'm probably going to have to thin out this gap to take on the 0.5 fabric, and I'll make a test to see how the fabric holds up. To do my test, I don't have a piece that's long enough. Maybe I do. Just gonna take this. See, I'm trying not to drop the camera. There. I'll take this off. Now, what I do to test these is I just put them on the end. I really need to set up my webcam because this sucks monkey balls. I set it up on the end of the tube. I coil it up, move it up, give myself some room, and right-handed working with his left. Yeah, so there. I give myself some room, turn on the vacuum, and then put it against a flat surface. And that's how I see how close I can get to a surface before it shuts down. It collapses on itself. It's not perfect again, but it's one way. This stuff is not bad. Let's say for regular use when I know I'll be doing nothing but surface work. But I got a bad feeling that maybe if I make cuts in it, like the curtains in freezer rooms, when they go from one section to another, they have this hanging plastic, which might just be this stuff, but thicker. And just to give it more, a little bit more sweeping room, because right now, as soon as it's curved, it's not a good idea. It just, like that. See, you could press down on it, and it takes a while before it crushes. And these little steppers, I mean, they're not that strong. You gotta respect the machine and its capacities and capabilities. So live and learn.